All right, so today we're talking about Pythagorean theorem. You guys learned about Pythagorean theorem in middle school. So Pythagorean theorem, we use that when we have a right triangle. That's important. We only use Pythagorean theorem if we have a right triangle. How do I know if my triangle is right?
If it has 90 degrees. Wait.
Has that little box. So I highlighted the word right triangle and then I highlighted that little box. That's what we're looking for, okay? So I know that my triangle is right if I have that little box in the corner. So our right triangle has two sides called the legs. That's going to be the A and the B side. And then the side across from the right angle, that is called the hypotenuse. And there's a couple of things that I want you to know about the hypotenuse. So we're going to call it C. It is always opposite the right angle. Opposite the right angle, and it is the longest side. Okay? So the hypotenuse is always opposite the right angle, and it's the longest side. Every single time I do a Pythagorean theorem question, I label my triangle A, B, and C. Can someone let Kaya in, please? Every single time. Oh, perfect. Every single time I label my triangle A, B, and C. The purpose of that is so that I don't mess up when I use A squared plus B squared equals C squared. Okay? So we're going to start off. Our first example. So it says solve for the missing side of the right triangle. I'm going to label one side A, one side B, and the missing side is C. How do I know? Say again, Cheyenne. It's what? It's the longest side, and what else? Javier, you said something else.
It's the hypotenuse.
It's the hypotenuse. What is the hypotenuse? It's opposite the what?
Right.
Opposite the right angle. So Pythagorean theorem says that the sides squared, A squared, which is 5, plus B squared, which is 12, equals the hypotenuse squared, which is just C. So 5 squared, that's 5 times 2, right? 5 squared is 5 times 2. I love that. It's 5 times 5, right? Don't make that mistake. 25 plus 12 squared, 144, equals C squared. 169 equals C squared. So how do I unsquare something? Square root. Good job, Jordan. So I have to take the square root. So I'm going to rewrite this over here so you can see it. C squared equals 169. So I need to unsquare that C. So I have to take the square root of it. But remember, with equations, whatever you do on one side, you have to do on the other. So I have to take the square root of both sides. So the square root of C squared is C. How do I find the square root of 169 in my calculator? I don't know how to work the buttons. Need help. I don't know what it looks like in my calculator. What buttons do I use to find square root? Oh, good. Jordan knows. Jordan said push the blue button, the second. Push the second button, and then go to x squared. And right above the x squared in your calculator, you're going to see a blue square root symbol. So that's why we push the second feature. The blue button takes us to all the blue symbols. So second x squared, what is the square root of 169? 13. It is 13. Okay, it's 13. All right, the next one I'm going to set up, and then you're going to show me how to do it on your calculator because some of you guys are just kind of willy-nilly not thinking about it, and then you're going to get to your homework and not be able to do it. So what do I do first? Label my sides. Does it matter which one I call A or B? No, those are interchangeable. So I'm going to call this one A and this one B, but my hypotenuse is always opposite the right angle, C. So when I set this one up, my missing side is A. A squared plus B squared equals C squared. I don't have a value for A, but B is actually 9. 9 squared. And C is 15. 15 squared. What is 9 squared? 81. So I have A squared plus 81 equals, what's 15 squared? It's 225. Does everyone know how to square something in their calculator? Are we putting 15 times 15 in our calculator, or are we using the squared button? The squared button. Okay. What do I have to do to solve this? I'm trying to get A all by itself. Minus 81. Ms. Taylor, will you pick your head up, please, and thank you. So A squared equals 144. How do I unsquare this? Whatever I do on one side, I have to do on the, I'm coming around to check. No shout outs. Show me how to do the square root in your calculator. Mrs. Banko, you want to check? Yep. Square root. Show me how to do it. In your calculator, square root. How do you find the square root of something? How do you use that symbol? Second, x squared, 144. What do you get? Enter. Perfect. Good job. Try to see the square root. Show me. You can do it ahead of time. I can see if you've got it on your calculator. Perfect. You got it? So second. And then you see the blue, all the blue information on your calculator you get to using the second button, and the x squared right above is the square root because they're inverses. So press that button. 144. Enter. There you go. Good job. Good job. Good job. I see it right there. Show me. Yeah. Show me how to do x squared or square root of something. Is that your work right there? So how do you find x squared? 144. Perfect. Are we all good? Everyone can find it? Got it? Okay. Good job, you guys. Awesome. So what is the square root of 144? It is 12. Okay. So how did you what?
We kind of did it in the other problem too.
We did do it in the other problem. All right. So because solving the missing side of a right triangle involves taking square roots, it's not always going to end up that you have a perfect square. So when you take the square root of a number that's perfect, that is not a perfect square, you're going to get an irrational number. This is a decimal that goes on forever. That's what irrational means. It's a decimal that goes on forever. So when we end up trying to take the square root of a number that's not a perfect square, we're going to have to do some rounding, okay? Typically, it will tell us to round to the nearest tenth, and that's what we're going to do. Sometimes you're going to see directions that say, express your answer in simplest radical form. Now, that is not a Math 1 standard. It's Math 2 and Math 3, but I'm still going to show it to you because I think it's good for you to see what it looks like. So when you get into Math 2 and Math 3 and you're actually learning it, you've seen it before. I'm not going to test you on it, okay? So we're typically going to round to the nearest tenth. That's what we're typically going to do, round to the nearest tenth, okay? So I need to label my sides, A, B, and C. Which one is C? The one that's across from the right angle. So does it matter which one I call A or B? No. Set this up for me, Cheyenne. What's this going to look like?
5 squared plus 5 squared.
Perfect. Excellent. What is 5 squared? 25 plus 25. So 25 plus 25 equals 50, yes, but we're working linearly, right? So we still have to say it equals c squared. How do I unsquare that? Square root.
7.0.
So hang on a second. So our first answer is going to be an about. It's not an exact answer. It's about. So I'm going to use not an equal sign, but this little squiggly equal sign. That means about. It tells whoever's looking at my answer that I rounded. Okay. And so you said it's about 7.1. Did you round it to the nearest tenth? So it's about 7.1. Okay. So I want to show you what it looks like as a simplified radical. Again, you're not going to be tested on this, but I want you to see it. So we have the square root of 50 equals c. I want you to think about the square root of 50, and I want you to think about essentially the number 50. What two numbers can I multiply together to get 50, but one of them is a perfect square? Like 4, 9, 14, 25, 36. Are there any perfect squares, numbers that are on the diagonal of your times table? I gave you guys all a times table, right? Number that is on the diagonal of your times table that you can multiply to equal 50. 25 and 2. Excellent. So the square root of 50 is also the same thing as the square root of 25 times the square root of 2. But what is the square root of 25? 5. It's 5. So this is actually 5 times the square root of 2. And this answer is exact.
The square root of 2 is like.
We just leave it like that. We don't know what the square root of 2 is without rounding it, but we can leave the square root of 2 under, like we can say the square root of 2 and be exact, okay? So are you going to be tested on simplifying radicals? No. Could I maybe give you a bonus question?
Yes.
That has like some multiple choice? Yeah, for sure. Okay. Typically we're going to round to the nearest tenth. Okay, label my sides A, B, C. Anyone? Which one? What side is missing? Call it A. A is missing. B and C. Set it up for me, Olivia. Set it up.
A squared plus 4 squared equals 8 squared.
Perfect. So let's see. What is 4 squared? 4 times 2 is? Oh, 4 times 4. Good job. And 8 squared is? Good job. What do I do next? Subtract 16 from both sides. So A squared equals? So I have to unsquare that. Take the square root of both sides. A is about
7 or 6.9.
Is it 6.9 or is it 7?
Well, the first one is 6.9, but I rounded it to 7.
So what is it? What are your decimals? 6.9 what?
6.92.
So does the 2 make you round the 9 up? Okay, so it's 6.9. Does that make sense?
Yep.
Okay, so let's look at this as a simplified radical. So the square root of 48. Well, that's the same thing as saying 16, which is a perfect square, times 3. But what is the square root of 16? So 4 root 3. So that's the exact answer. Again, you're not going to be tested on this, but it's good to see it. It's good to know where it comes from, right? A perfect square times a non-perfect square. That's how we're doing that. We're taking a perfect square times a non-perfect square. Questions? Miss Kanaya, you good? I thought you had a hand up. Do I need to go back up? What do you got? Okay. All right, so I'm going to move on. So often, Pythagorean theorem questions arrive in the real world. If you've ever framed a house out, or if you've ever cut your own butcher block countertops, right? Those are real world examples where you have to know how to use Pythagorean theorem to figure out your measurements, okay? So in this example, we have a 12-foot ladder that's leaning against a wall. And it says that the base of the ladder, that's the bottom of the ladder, is 4 feet away from the wall. So this is the base of the ladder right here. The base is this guy right here. And it's 4 feet away from the wall. This ladder is actually representing my hypotenuse. So the wall, I'm going to call A. This measurement along the floor, I'm going to call B. How high up along the wall does the ladder reach? So we're trying to solve for what variable there? A. Set it up for me, Garrett, please and thank you.
A squared plus B squared.
What is B?
4
Yeah, so 4 squared. Perfect.
squared, equals 4 squared.
Perfect. Excellent. Very nice. So A squared plus 16 equals 144. Angelina, how am I going to get A squared all by itself? I'm going to subtract what? 144 minus 16. So A squared gives me 128. Good job. Coming right over there, ma'am. Square root of both sides. A. Kanaya. I'm coming. Someone figure out what the square root of 128 is. It says to nearest tenth.
I think about 11.
You do that in calculator. Second.
What? Yeah, this is what so I'm just showing you. Yeah, and we'll practice. Okay. What did we get for that? I'm sorry.
A is about 11.3.
11.3 puppies, 11.3 donuts. This is a real world example. 11.3
Feet high.
feet. Good job. Okay. Equilateral triangle. What in the heck is an equilateral triangle? I don't even know what that is.
Equilateral? Oh, that's when all the sides are equal.
Oh my gosh, let's write that down. All 3 sides have the same.
Literally in the name. Equilateral.
You're right. It really is in the name. I don't know why I didn't notice that. All 3 sides are the same. They have the same measure. I'm going to draw a picture of it because I want to talk about this. It says that all of the sides have a measure of 10 inches. So 10 inches, 10 inches, 10 inches. And it's going to ask me to find the area of the triangle.
Okay, so that's the base times height divided by.
Yeah, so the area of a triangle is the base times the height divided by 2. So I have a question. What is the base measure of my triangle? 10. So this guy right here is my base. What is my height?
70.
Is it?
I don't know, is it?
Well, you tell me, where does the height go?
Yes,
Isn't the height perpendicular to the base? Isn't that the definition, right? They're always perpendicular. So it is 10? Ooh, I think I have to do this. I have to do this.
Yeah, see, you have to split it in, so it's
So hang on a second. What should be 5?
the height.
No, let's look. So what are we looking at, really?
You're looking at the right.
Yeah, I'm looking at part of a right triangle. That equilateral triangle is divided up into 2 congruent right triangles. So in order for me to find the height of my equilateral triangle, I need to figure out the B side of the right triangle.
So you split 10 in half.
It's not splitting it in half. This is going to be 5, but yeah, We have to actually use Pythagorean theorem just to find the height. How's that going to look?
That's gonna look like 5 squared times b squared
Plus b squared.
plus b squared equals 10 squared.
Perfect. 5 squared is
125.
plus b squared equals,
100.
thank you, ma'am. What do I do to get b squared by itself?
25.
Subtract that. Good job. Thank you, ma'am. So b squared equals 75. So b equals the square root of 75. I'm going to leave that like that for a second because that's just the height,
Oh.
right? Isn't that my height?
Yep.
Okay. So that's the height of my equilateral triangle. What is the measure of the base of the equilateral triangle? No, it's not 5. What's the base? The whole base of the equilateral. It's 10. So do you guys see that? So we took that whole equilateral triangle and we split it in half to get the height. We had to find the perpendicular. So that's what this picture is right here. But the whole base is really 10. So to find the area, I have to take 10 times the square root of 75, and then take that whole thing and divide it by 2. So let's write it out first. So 10 parenthesis square root of 75, close my parenthesis, all over 2. So in your calculator, 10 times the square root of 75 equals, and then divide by 2. 10 times the square root of 75 equals, and then divide by 2. So 10 times the square root of 75. You should be typing this into your computer. Don't wait for your neighbor to give you the answer. 10 times the square root of 75 equals, divide by 2. So 86.6 divided by 2 is 43.3. Final answer, 43.3. What are we talking about? Area. So square inches. It's inches. 43.3 square inches. I am aware of the time. Remember, our homework assignment is not due till Monday because we have a quiz tomorrow and then Friday half day. I'm going to skip example number 5. Okay. I'm going to skip example number 5. I'll make a video so you can watch that tomorrow after your quiz and finish that up. I want to jump to this idea of the Pythagorean theorem and its converse. Okay.
Do you want to give it to me and I'll take it to the testing room?
It's in his folder in there, okay. And he can only do corrections. It's period 1, and it's in AB. Yeah. Okay, so I want to talk about this idea of the converse. So I'm going to kind of slide up to right here. The converse of the Pythagorean theorem. The converse says that if you take the measures of the sides of a triangle and you square and add up the 2 shorter sides, and it equals the square of the longer side, then it has to be a right triangle. So the Pythagorean theorem said when you have a right triangle, the legs squared added together equals the hypotenuse. This says, hey, you don't know what kind of triangle you have. You don't have any picture at all. You just have measurements, okay? You don't have any picture, you just have measurements. And so for that, when you don't have any picture, you only have measurements. For that, that means you have to just use the Pythagorean theorem. You just need to know which side is your hypotenuse. So what do we know about the hypotenuse? Which side is always the hypotenuse? The longest side. Yeah, the longest side. So I always circle the bigger side and I label it C. I always circle the bigger side and I label it C.
Because the C is always the biggest number.
Because C is always the biggest number. Yes. And then remember that A and B are interchangeable. It doesn't matter which one you call A or which one you call B. So I just set this up as 28 squared plus 45 squared equals 53 squared. And in my calculator, I figure out what 28 squared plus 45 squared is. I just do that all at one time. What is it? 2,809. And then I figure out what 53 squared is. 2,809. So is this a right triangle? Yes, this is a right triangle. Okay. Let's check and see if the measurements that we have in example B give us a right triangle. 17 squared plus 22 squared, and it should equal 29 squared. So what is 17 squared plus 22 squared? 773. And 29 squared, I think, is 841. Oh my gosh, those don't equal each other. So put a slash through your equal sign and write not a right triangle. Okay. So I'm going to freeze the screen. I'm going to freeze, and you are going to set up example C and tell me what you discover. Do it the exact same way that I did. I want it set up the exact same way. Either something equals something or something doesn't equal something. What did we discover? How come? What measurements did you get?
I got
Yeah, 1,521 equals 1,521. So this is a right triangle. Okay? This one is a right triangle.